In this video, we talk about two ideas, the idea of position and the idea of displacement, and we'll talk about those as we go through here. But we want to deal with what we call rectilinear motion. The rectilinear motion is just the motion that takes place along a straight line. All right, the line typically we'll call the s-axis, and the s-axis for most of the time will be either a vertical axis or a horizontal axis, but it could be tilted at a 45-degree angle or anything like that. So let's take a look at an object. Suppose we drop an object and it falls under the influence of gravity. This would be an example of rectilinear motion. And let's see if we oops, that's wrong one. Okay. Let's bring up the previous one here. Okay, here's the situation. Notice we have an object. It's located 96 feet above, say, the surface of the Earth. All right, and the object, if we drop it, of course it falls. It starts out slow and goes faster as we get towards the bottom, get towards the end of it. All right, if we can relate this to a curve, and this object took place along a straight line, it just fell straight down. But this curve is going to be, well, the height of the object is going to be the second coordinate, give us the height above the horizontal axis, and the time is going to give us the first coordinate, the distance to the right of the vertical axis. And so we'd have this curve is called the position versus time curve, because position is marked off on the vertical axis, time on the horizontal axis. And if we let this go again, notice this is what this would look like. Okay, it looks like it's a parabola, and I'll give you the equation for that parabola in just a few minutes. All right, but be careful. I don't want you to be confused. This is not the path of motion of the object. The object is falling straight down along a line. This is just gives me at each time, for instance, at 2 seconds, it looks like this object would have been at about 24 feet. Okay, and we'd be able to calculate that in just a few minutes. Okay, and so let's take a look here at this relationship. This function, the position function for this object would have been s of t. S represents position for some reason. I don't know why it's not P or something like that. But in this case, it would be 96 minus 16 t squared. Notice when t is equal to 0, S of 0 is equal to 96 because it started when time was 0. That was when we let it go, and it started 96 feet up. All right, S of 2 is going to be 96 minus 16 times 2 squared. That would be 96 minus 16 times 4, 64. And notice 96 minus 64 is about 32. And I think if we looked at that a few minutes ago, we had guesstimated it about 24, but that was a rough guess that we made from a graph. So anyways, this is how the position function works. Here's another example of rectilinear motion. All right, and this example of rectilinear motion, all right, is a piston moving in a cylinder. And so let's see, let's let the piston go here. And notice as the piston moves in the cylinder, it moves up and down, but of course along a straight line. And let's see, the position versus time curve in this case would look as follows. All right, notice as the object moves up and down and time passes, as the object moves up and down, we move up and down on the graph. As time passes, we move further to the right. And this is a sine curve. And notice this thing started out at 8 feet, and it has an amplitude. The radius of this is 2 feet, so its amplitude when it hits the top, it's at at 2 feet higher, and at the bottom it's 2 feet lower. So this would be, and by the way, it goes through 2 cycles in 10 seconds. So let's see, so what would this curve be? All right, well, all right, first of all, let's see, as t goes from 0 to 10, all right, what's happening to the angle, to the argument of sine? Well, if I would divide by 10, all right, I would go from 0 to 1, okay? T over 10 would go from 0 to 1. But let's see, I wanted to go through 2 revolutions, which is 4 pi, so I'll multiply by 4 pi, and 0 will be less than 4 pi t over 10, which is less than or equal to 4 pi. And I could cancel a 4 with the 10, leaving a 2 and a 5. So this would be 0 is less than or equal to 2 pi t over 5 is less than or equal to 4 pi. So this must have been the argument of sine. So we had the sine of 2 pi t over 5. That was the sine. Remember, our amplitude was 2, so we'd multiply this by sine by 2, and we had our baseline was at 8. That's where it started and ended. So this would have been our function s of t. This would have been our function s of t. This would give us a position. If I put in a time, this would tell me how high the piston was in that cylinder. Okay. All right. Let's take a look at this. So what we want to do is we want to talk about displacement and average velocity. And remember, our function here now is s of t, gives us position. And so let's take a look at this. So given our function, their position function, s of t is t squared minus 4t plus 3. All right, we want to find the displacement over the time interval from 1 to 2. Well, t is going to go from 1 to 2. Notice that there's a change in t, which we'll call delta t, is equal to 2 minus 1. That would be 1. Okay? All right, the position at 1 is going to be 1 squared minus 4 times 1 plus 3. And so that'll be 1 plus 3 is 4, minus 4 is equal to 0. So we started so at time t is equal to 1, we're at a position 0. And at t is equal to 2, we'll have 2 squared, which is 4, minus 4 times 2 plus 3. So this would be 4 minus 8 is negative 4, plus 3 is negative 1. Let me check that again. 4 minus 8 is negative 4, plus 3 is negative 1. So notice that basically our displacement is delta S. This is the displacement. This is the displacement, and that's going to be negative delta S will be negative 2 minus 0, which would, I'm sorry, negative 1 minus 0, which would be negative 1. The displacement is basically just the change in position, whether it be positive or negative. Our average velocity, all right, is going to be the change in position divided by the change in time. This would be the average velocity, and that would be negative 1 over 1, which would be negative 1. So the average velocity over this interval is negative 1. Let's see what we've done here. All right, I started out at 1. All right, and I went to 2. All right, and notice when we went to 2, we went down to negative 1. So the change in position was, all right, negative 1 minus 0 is negative 1. Negative meaning we've gone in the negative direction, and 1, we've gone 1 unit in the negative direction. All right, the So this vertical change was -1. The horizontal change was 1 second in time elapsed. So our average velocity is -1/1. Okay, and our average velocity, by the way, would be kind of like the slope of this secant line here. Okay, the rise over run for that secant line. Let's take the same function, but now let's look at the position. Oh, I didn't change these here. From 0 to 5. So at time t is equal to 0, s of 0, without too much ado, is going to be 3. S of 5 is going to be 5 squared, 25, minus 4 times 5, 20, plus 3. This is going to be 5 plus 3, or 8. All right, the change in position, this is the displacement. The displacement is going to be 8 minus 3. That's negative, that's going to be 5, not -5. So our position has increased by 5 units. The change in time is going to be 5 minus 0. That's going to be 5. And notice in this case, the average velocity would be the change in position divided by the change in time. That will be 5/5. 1 will be the average velocity. For this curve, let's see what we've done here. All right, notice at time t is equal to 0, we're at the point 0, 3. At the time t is equal to 5, we're at the point, excuse me, 5 and 8. Okay, and so what we've really calculated, the average velocity is going to be the slope of this secant line between those 2 points. All right, and so that's the idea. All right, position function gives in terms of s, tells us where the object is located at time t. All right, displacement is the change in the position function, delta s, and average velocity is the displacement divided by the change in time, delta s divided by delta t. Speed or velocity is equal to is rate divided is distance divided by time. Okay. All right. In the next one, in the video, we'll talk about instantaneous velocity.